In standard software engineering, a passing unit test grants permission to merge code. In a formally governed architecture, a passing test grants nothing. If a code mutation violates the established architectural law, the system halts entirely. Code that functions correctly is meaningless without cryptographic custody. The system demands an unbroken chain of evidence, verifying exactly who authorized a change and under what specific rule, before that code is permitted to run. Any unauthorized mutation creates an immediate runtime divergence. The mathematically sealed baseline, the version of the system known to be safe, no longer matches the live environment. The architecture responds with absolute finality. The front door denies access to the modified runtime. There is no workaround. A developer cannot patch around this denial. They cannot manually copy new hashes into the sealed configuration to force the system to accept the modified bytes. System integrity requires an environment where any unauthorized mutation instantly and permanently locks the entire operating tree. ConstructOS operates on a primary directive. It strips all design authority away from human developers and autonomous AI agents. The developer is an executor, not an architect. In this environment, no one has the authority to invent architecture on the fly. You cannot infer missing logic, and you cannot fill semantic gaps by relying on conventional software engineering assumptions. Every change must occur through a gap closure campaign, a regulated, mathematically bound process for reconciling runtime code against external architectural laws. This process guards against a specific threat: the engineer who fixes a localized bug while silently destroying the safety invariants of adjacent subsystems. To be valid, a system mutation must execute a state preservation contract. The developer must prove, mathematically, that removing the defect did not trigger a systemic regression.